Hello and welcome. Thanks for taking the time to join us today to talk about modernizing your application delivery with SUSE and AWS. As we run through the webinar, please feel free to drop any questions into the chat and we'll cover them, as many of them as we can, in Q&A at the end of the presentation. For nearly 10 years, SUSE has been collaborating closely with AWS, helping thousands of our joint customers realize their business potential. SUSE Linux Enterprise Server and support for running certified SAP applications provide an optimal platform for running your mission-critical Linux-based workloads on Amazon EC2. And now, helping you maximize developer agility for microservices workloads with SUSE Cloud Application Platform on Amazon Elastic Container Service for Kubernetes, or EKS. My name is Jay McConnell, and I'm a Partner Solutions Architect with AWS. I'll start off by covering some of the fundamentals around modern development practices, and then I'll hand over to Brent from SUSE, who will discuss Cloud Application Platform in more detail. And then finally, we'll hear from Yugendar and Srikanth from Wipro on how they built a next-generation digital asset management solution. Your customers want innovative products that have features that meet their needs. So how do we ensure that our processes are optimized to delivering what customers want? A key component is agility. Agile businesses favor experimentation over elaborate planning, customer feedback over intuition, and iterative design over traditional big design upfront development. And once this agility is achieved, we can shift resources from operations to development. Our developers can experiment more, which lets us bring new ideas to the market faster. If we collect and analyze that customer feedback, and then use this to guide new experiments, we have built a flywheel that not only enables us to deliver innovation at pace, but also keeps the focus of that innovation squarely on our customers' needs. Today, we'll see how SUSE Cloud Application Platform on AWS can help us to get this flywheel going. So we'd like to enable developers by allowing them to focus more on building applications. At the same time, practices like shift to the left, where more and more ownership is being assigned to development teams over how their applications are deployed, scaled, and interconnected, provides great opportunities for customers to increase agility and achieve operational excellence. There's a balancing act here, though. Without suitable tools, development teams can get bogged down in managing the details of packaging and deploying their applications. Let's spend a few minutes going over some technologies that can help us to reduce undifferentiated heavy lifting by providing abstractions and automation, while still leaving as much control as possible with our application teams. First off is containers. Now, SUSE Cloud Application Platform adds a layer of abstraction that uses containers under the hood, but takes the abstraction a level higher, so that the fact that there's containers there is almost invisible to the developer. Nonetheless, understanding the value of containers will set the stage for how and why further abstraction is useful. Containers fit modern application development patterns very well. They provide the ability to take the runtime engine, dependencies, and application code and package them into a consistent unit of deployment. This artifact or container image is something you can deliver to any machine or run locally, and you can be confident that it'll run properly because it's going to bring along with it the proper runtime engine, dependencies, and configuration. Another enabler of agility is microservice architectures. Traditionally, most applications were monoliths, a single code base to rule them all. As an application grows, so does the complexity of adding new features and updating dependencies. The complexity of releasing changes is also tied to the application, meaning the more complex the application, the greater the time and risk associated with creating new releases. These problems present a significant barrier to remaining agile at scale. Microservices address these challenges by splitting the applications up into small services, each with a singular task and standardized interface. Now teams can choose whatever technology suits their needs and their team skill set. Teams can also iterate rapidly as the complexity and impact of change is drastically reduced. While microservices architectures allow us to remain agile as our application grows, they also present additional challenges in achieving observability. Instead of a single code base running on a set of hosts, we now have many autonomous interconnected services. Identifying performance bottlenecks and troubleshooting failures can be a lot more difficult if we don't ensure that monitoring is being done properly across all microservices, and is aggregated to a central point where real-time metrics and alarms are provided. Onto CI/CD, and I'm going to focus on the CD bit. Continuous delivery is a software development practice where code changes are automatically built, tested, and prepared for a release to production. Continuous delivery lets application developers automate testing beyond just unit tests, where they can include UI, load, integration, and API reliability testing. So they can verify application updates across multiple dimensions before deploying them to customers. Practicing CI/CD has a dramatic effect on agility, as you can see from these numbers. Automating broad and deep testing means that developers have much higher confidence that code updates are not going to cause failures. And when there are issues, customers are not impacted, and the developer gets really detailed feedback fast, allowing them to fix the issue and move on to the next feature. At AWS, we believe that security is job zero and of utmost importance. But as Amazon CTO Werner Vogels has said in the past, we need to let builders build. Traditional practices of providing centralized security audits on software at the end of a development lifecycle can be an obstacle to agility. Having security at all layers and all parts of the application lifecycle give developers a faster feedback loop so they can address security and compliance concerns in a more iterative manner. An agile security model is collaborative, frequent, iterative, and continuous. Okay, so we've covered some of the key components for successfully building modern application practice. Let's have a look at the AWS services that help customers implement these and how they're used by SUSE Cloud Application Platform. SUSE Cloud Application Platform's deployed onto Amazon EKS, which provides a fully managed, highly available Kubernetes control plane. In addition to not having to manage the Kubernetes control plane, customers running Amazon EKS benefit from the suite of AWS services that help to secure, monitor, and automate operations. A common thread across the abstractions and patterns that we've talked about so far is letting builders focus on building. So to hear more about how SUSE Cloud Application Platform enables exactly that, I will hand you over to Brent Smithhurst from SUSE.
Thank you, Jay, and hello, everybody. I'm Brent Smithhurst, and I'm the Global Product Marketing Manager for SUSE Cloud Application Platform. And if I can get the slide, there we go. So at SUSE, we definitely share your enthusiasm for containers and Kubernetes. However, while Kubernetes is the dominant container management platform for operators, it doesn't offer anything for developers who write and create containerized applications. That's why SUSE Cloud Application Platform chose to use the Cloud Foundry application runtime to add functionality for developers on top of Kubernetes. For those who don't know, Cloud Foundry is an open source project managed by the Cloud Foundry Foundation, of which SUSE is a platinum member. SUSE Cloud Application Platform allows developers to containerize, deploy, run, and manage an application using a single CF push command from the CLI, or even by specifying a GitHub repo in the UI. From there, it automatically identifies and pulls in the required language libraries, frameworks, and other dependencies via build packs. There are also open source service brokers to automatically create and bind services to applications. And once an application is deployed, the platform automates lifecycle management of the application by assigning appropriate resources, managing routing, load balancing, scaling it up and down, and much more. So SUSE Cloud Application Platform eliminates manual IT configuration and helps accelerate innovation by getting applications to market faster. Developers can serve themselves and get apps to the cloud in minutes instead of weeks, all while staying within IT guidelines and without relying on scarce IT resources to perform manual configuration each step of the way. Streamlining application delivery like this opens a clear path to increased business agility led by enterprise development, operations, and DevOps teams. And it does it all within Kubernetes, which many organizations are already using. Key features and benefits include boost developer productivity with the one-step application deployment. So again, developers simply push an application from their desktop using the CLI or web UI. And SUSE Cloud Application Platform automatically configures The entire environment provides the required dependencies, binds the required services, and deploys the application as a container, which is then automatically managed and scaled. It does this using open source build packs that allow developers the flexibility to work with the best choice of language and framework for any task. It allows you to reduce complexity and increase IT efficiency at the same time with a lean platform for rapid application delivery at scale. SUSE Cloud Application Platform increases efficiency by running in lightweight containers instead of resource-hungry virtual machines. It consumes a fraction of the memory footprint of other Cloud Foundry distributions while being as fast or faster to recover and scale. It's fault-tolerant and self-healing with high availability for critical components. SUSE Cloud Application Platform monitors the health of all containers and automatically restarts failed ones. And finally, it allows you to maximize ROI with industry-leading open source technologies that leverage your existing investments. It's 100% open source technology, including, of course, SUSE Linux Enterprise Server, Kubernetes, Cloud Foundry, and the Stratos UI. And these protect your investment and lower your risk. So studies by the Cloud Foundry Foundation show that organizations dramatically decrease the time it takes to deploy applications after they adopt Cloud Foundry. This information on the screen is from an April 2018 survey. And prior to using Cloud Foundry, typical users deployed and configured cloud applications manually, or they used custom install scripts or configuration management tools. Using these workflows, a majority of respondents required more than 3 months to deploy a new cloud application. Only 16% say it took them less than 1 week, including only 6% that could deploy a cloud application in less than 1 day. However, after moving these applications to the Cloud Foundry application runtime, these times dropped dramatically. Now, 46% of respondents report cloud app development cycles of under a week, including 25% who report it takes less than a day. Using cloud application runtime, only 18% of respondents report application development cycles of over 3 months, which is a decrease of 33 percentage points from before. Another key finding of the survey was that organizations use Cloud Foundry to deliver more apps in less time. So more than a third of Cloud Foundry users save a few months or more per application development cycle. 10% report saving more than 6 months. Nearly a quarter of users report saving $500,000 per application development cycle, 17% of whom save more than 1 million. So an app a year company can transform into an app a week company, and that has a compounding effect when it comes to saving time and money. On average, users reported savings of 10 weeks of time and $100,000 per application development cycle. And that's why SUSE Cloud Application Platform uses the Cloud Foundry application runtime. It's a certified distribution that is containerized and easy for Kubernetes users to get started with. Compared to other non-containerized Cloud Foundry distributions, we have a much smaller memory footprint, are 100% open source, and again, use SUSE Enterprise Linux. SUSE Cloud Application Platform is flexible to meet the needs of both developers and operators. It does require Kubernetes to operate. The bottom of this diagram shows options for the best operator experience. SUSE CaaS platform is offered as software that you operate yourself on a private or public cloud, such as Amazon EC2, or simply within your own data center. Or, of course, Amazon EKS is a great option if you prefer to use a hosted and fully managed Kubernetes. The top of the diagram shows options for developer experiences. On the left, you have what we call DIY DevOps automation, meaning you can create and run containers any way you like. But over on the right is the SUSE Cloud Application Platform, which we believe is the best choice for a true cloud-native developer experience. Our understanding of the possibilities for leveraging both Cloud Foundry and Kubernetes extends beyond the obvious. At SUSE, we've taken containerization to heart and created a unique distribution of Cloud Foundry that is itself containerized. This makes SUSE Cloud Application Platform efficient and lean, again running in lightweight containers instead of resource-hungry virtual machines. Containerization means you can deploy SUSE Cloud Application Platform easily anywhere using Kubernetes. Once deployed, the application platform is managed by Kubernetes, ensuring that your Cloud Foundry environment remains available, automatically scales without downtime, and manages load according to your established criteria. And again, you can use Kubernetes to manage other containers as well. So you can bring your own, whether they're backing services for your Cloud Foundry web apps, third-party containers that you want to use, custom containers and microservices you've built, or even traditional legacy applications that you've dropped into containers. You can manage them all with SUSE Cloud Application Platform. SUSE Cloud Application Platform is hybrid and extensible to AWS services. Because it runs inside Kubernetes, you have options ranging from deploying it on SUSE CaaS platform in your own data center, deploying on Amazon EKS, or even deploying it on SUSE CaaS platform on EC2. But no matter where it's deployed, the included AWS Service Broker allows applications to bind to and consume services hosted by AWS, including Amazon RDS for MariaDB, MySQL, Oracle, Postgres, SQL Server, and more. So to sum up, for nearly 10 years, we've been working with AWS, helping thousands of customers move enterprise workloads to the cloud. And together with AWS, we provide an optimal platform for running your mission-critical Linux-based workloads, and now helping you maximize developer agility from Kubernetes-based container and microservice workloads. And with that, I'll turn it over to my colleague Yugender from Wipro.
Thanks, Brent. Hello, everyone. My name is Yugender Kandapalli, head the open source practice at Wipro and responsible for promoting open source adoption within an enterprise customers and transforming applications using the open source technologies. My colleague, Mr. Srikanth, and I will spend next 15 minutes to walk through how we have leveraged the AWS and the SUSE Cloud Application Platform to transform the digital asset management platform that we have created for our retail customers. So before getting into the how we have transformed the digital asset management platform, I would like to give a quick overview about how we have helped our customers together with AWS and SUSE. Wipro is an innovation-led cloud partner to many clients on AWS and SUSE next generation platform in their digital journey. And Wipro has developed innovative AWS and SUSE-centric solutions around the cloud migration, cloud management, data and analytics, and vertical industry-specific solution that helped Wipro to position as one of the top SI partners for AWS as well as for SUSE. And we have been working with both AWS as well as SUSE for the last 5 years in delivering the services around the software-defined infrastructure and software-defined solutions and the cloud solutions. As we see in the industry, especially the retail industry has been undergoing the business as well as the technology transformation. So to stay relevant and sustain the growth, the retail enterprises were expanding the product portfolios either through acquisitions and mergers or launching their new products. That has resulted in inheriting or implementing multiple warehouse management IT platforms to address multi-geo, multi-product requirements, which eventually led to lack of centralized view of inventory because of the data silos and lack of holistic view on order to shipment and fulfill and lack of real-time inventory view to retail stockkeepers and the e-commerce channels, resulting the bad customer experience. And most of the time, the retail storekeepers end up maintaining the data in Excel sheets to keep track of inventory positions within their retail stores. So to address these problems, the retail enterprises started looking at the option of consolidating the various warehouse management IT platforms into one, but which eventually led to a lot of investment in terms of time as well as the cost. That's where Wipro engineering team, in collaboration with Wipro retail domain team, developed a solution which we call it as a digital asset management platform, which we also called as connected warehouse management platform, which eventually provides the consolidated view of it. It gathers the data from the multiple backend warehouse management platforms and provides a single view about or consolidated view about the inventory and the inventory positions and about the warehouse operations and the orders data at, with a centralized view across the retail enterprise. So the solution primarily was developed. It's a web-based application, and on entire architecture we have developed using the open source technologies. And the front end was developed using the Angular and Node.js, and the business logic was developed using the Java and Spring and Spring Boot. And the NoSQL database is actually used to consolidate uh, the warehouse related information and the attributes into NoSQL, which is a MongoDB that we have used. And we have created an event management framework behind the persistence layer, which actually to synchronize the information from the multiple warehouse management platforms to the NoSQL MongoDB platform. And this entire application, the business application, has been deployed on Tomcat application server, and the underlying infrastructure that we have used, the VM-based infrastructure, deployed on a VM-based infrastructure. So we have been customizing the digital asset management platform, which is actually created as a framework within Wipro, and it has been customized to meet the requirements of the individual retail customers. And as we started scaling and rolling out these solutions to the multiple customers, apart from the functional challenges, we have faced a lot of non-functional related challenges, especially in terms of the agility and in terms of the scalability and availability and manageability. Coming to the agility, the application was primarily developed with a monolithic fashion. And though we have implemented a CI/CD platform, but not able to achieve the continuous delivery at scale, right from the provisioning of the infrastructure and spinning of the technology platforms and the technologies which is required to develop those components and testing those features and releasing feature-based deployments. So we were not able to scale. I mean, that was adding the significant delays to the rolling of the new services on digital asset management platform. The second challenge that we were facing was in terms of the scalability and elasticity. Due to seasonal load and regional load at the different intervals required to scale the entire platform instead of scaling the feature that has high consumptions. As the solution expanding to more digital channels and the more data is getting loaded into the digital asset management platform, we require more infrastructure to support the elasticity, which is actually increasing the cost, and it's becoming very, very difficult to manage the large infrastructure uh, to host the solution. The third challenge was the data services that we have created within the digital asset management platform, which has been consumed by not only the POS solutions, not only the internal solutions, but it has been actually consumed by the online e-commerce platforms as well as some of the partners, which actually force the system to be on all the time. That forced us to have a robust observability platform to monitor right from the infrastructure and the processes which are running on the application containers and the availability of the channels itself, right? So we were not able to have the complete integrated view to ensure that all the system and all the processes available all the time. And the fourth one is the manageability. And as I mentioned, as part of the agility, though we have implemented the CI/CD, but we were having the significant challenges in terms of onboarding the new technologies and doing the automated provisioning of the platforms and managing those platforms and monitoring the platforms was one of the biggest challenge that we have faced, since it was all these components was independently developed and independently deployed and independently managed. So we were not having the single holistic view about the complete the platform. That's where we were having a significant challenges in terms of managing this digital asset management platform. In order to address those about the challenges, we have started looking at the modernizing these applications, and we have looked at from the complete re-architecting these applications in a more of leveraging the emerging architectures like a microservices. And at the same time, we looked at some of those platforms which the next generation technologies, which is going to help us in addressing some of those scalability and scaling those functions selectively, and having the end-to-end observability out-of-the-box frameworks which can enable us to implement much more faster. So that where we started evaluating some of the container-based platforms, and then we have finally chosen to implement and migrate this entire solution on a microservices-based architecture onto the SUSE cloud application platform hosted on AWS infrastructure. So with this, I will hand over to my colleague, Mr. Srikanth, to talk about what architecture patterns that we have adapted and how exactly we have transformed and migrated these applications onto SUSE cloud application platform hosted on AWS infrastructure.
Thanks, Hugh. Thanks, team, for setting the right context. Hello, all. This is Srikanth here. I'm part of the open source team, and I lead the platform engineering. Here, I would like to present some of the key aspects of what we have done in terms of changing the solution and how we have leveraged SUSE cloud application platform capabilities to address some of those challenges. The objective here is to share our perspective in terms of what we have seen in terms of improving the overall solution, and what are the various features that we have leveraged from the SUSE cloud application platform to address the challenges, specifically around the agility, scalability, and the effectiveness of this aspect. So when we relooked at the solution, as my colleague mentioned, we focused on the microservices aspects while following some of the standard domain-driven principles. We also looked at some of the key aspects of bounded context. Here, I would want to touch a bit upon the way we have re-engineered the services. Typically, from a retail domain perspective, the bounded context we wanted to identify. For example, it could be an inventory, it could be a sales order, it's purchase orders, invoice, supplies, etc. Now, the key aspect here is that when we start looking at it from a domain bounded context perspective, it also leads us to create these domains, translate them into logical groups, spaces, for example, on the cloud application platform. So here we can see that our architectural aspects are seamlessly getting realized into the features of the cloud application platform. This helps us to already start seeing our architecture evolution by creating domains which are going to be spaces in the realization aspect. And again, the most of the microservices, so what we have created, they follow the share nothing principle, while this being a completely re-engineered solution. So we have the freedom to really design them in more share nothing approach, so that each of the entities had their own data stores, which are acting as a system of engagement and system of record. And again, the advantage here is also that the key aspects of leveraging some of those off-the-shelf features, services, which I'll touch upon from cloud application platform of SUSE, that helped us to sort of streamline the implementation aspects. The MongoDB, for example, has been selected for the system of record and engagements, but we have a plethora of options from a development standpoint that you could choose from the SUSE cloud application platform. And again, when we look at some of these typical aspect of the microservices is also the need to have data synchronization. That is, there are some scenarios where some of the microservices would need some information, read-only information, some common data that would be required for the functioning of the microservices. Typically, what we call it as a data synchronization capabilities. And those things, again, there are a plethora of patterns that you can follow. What we thought was to look at some sort of a event broker. Now, again, we leverage the RabbitMQ, for example, here. And again, the advantage here is that some of these services like RabbitMQ are available as services in the cloud application platform. So that helps us to make sure the architecture is more native and more easily packageable and easily manageable. Another aspect is that predominantly the services have been built on the Spring framework. Again, the advantage here is to make sure from a cloud application platform standpoint, the developers are completely oblivious to the expectations, because the build packs are there, which can automatically be provided. The entire dependency management is taken care. So that helps. That also helps us in bringing in more consistency in terms of developing the application and the microservices within this. And one of the key aspects of the solution, the digital asset management solution, is to be able to provide personalized dashboards. The key aspect here is that the actual personnel, the actual stakeholders who will leverage the solution, they will be part of the warehouses, the buildings, where they may not have the access to the IT systems as frequently as they expect. So the expectation here is to have an adaptive, responsive UI-based applications. So the microservices have to be scalable, have to be real-time, and hence, again, that's another key aspect of the platform. So we have developed using Node.js and Angular. Again, just to highlight, some of these build packs are available as Node build pack, and also, which again helps us to expedite and accelerate the development. And from a developer standpoint, it's predominantly just one push button, and then the whole dependencies are taken care. So that's one of the key aspects we have noticed. And also from the application standpoint, because it's going to be running on different handheld devices with minimum keystrokes, the need to design the solution much more responsive, and hence the need for highly scalable aspects. And also another interesting aspect here is that the operators, they interact with the inventory will be across geo, and the inventory units information is required on demand from various locations. And hence we need a platform which is distributed, which is scalable across regions, and it should be scalable on demand. Something like an auto scaling aspects also come into picture. And that also will address one of the requirements in terms of how you can scale the solution on demand at runtime with minimum intervention. And the challenges also is in terms of providing information regarding the stock keep units in the SKUs in terms of other inventories from different locations, providing alert mechanisms and all, which also means that the applications have to be highly available, and they should be highly manageable. So these are some of the aspects that we have considered leveraging the cloud application platform's features. The deployment view, what you see here is a very simplified view, while there are many more solution microservices that are there. For the simplicity, we have just mentioned a few of them, and you can actually see that it can be deployed across the zones. And the key aspect here is that some of the core operational aspects are completely oblivious from a development standpoint, which makes it much more seamless from a development standpoint. And a few other aspects which I wanted to touch upon here, what we have leveraged from the SUSE cloud application platform. So one of the concepts here is the services aspect. So what it means is that if you want to leverage some of those backend as a service, for example, or some of those stateful services, or some of those external services which are required as part of your solution, there are multiple ways to manage, implement them. One of them is to leverage the services which are offered as part of the Cloud Foundry marketplace, from which the users can actually provision the reserved resources on demand. And for example, any of the databases, whether it can be shared or dedicated, or it could be externalized SaaS services. The advantage here is that these services are exposed as a factory instances. So from a developer standpoint, they're very loosely coupled, and you could actually, it makes them more location independent, and that actually brings us to a clear boundary in terms of what is focused on the business logic of the service versus what are the external dependencies. So your dependency management is also well managed in that way. And you can also have one of the services, if they are completely deployed as traditional services on Kubernetes, for example. Even you can access them through the tradition as a through service broker aspect. So you have multiple patterns here, and depending upon the our requirement, we try to make sure everything is native in the cloud application platform so that it is easy to manage, and that's how we were able to expedite our journey of acceleration delivery. Another key aspect of the solution is in terms of logging. Again, you have a plethora of options here. You could actually leverage the Cloud Application Platform log management service, which is available again as part of the Cloud Foundry marketplace, which actually helps us in reducing the amount of code that needs to be written in the application services. So typically when we develop applications, one of the key challenges we face, especially in a microservices world, is the consistency and the governance around the service implementation. While the design is taken care, but on the implementation aspect, you need some consistency so that the services are behaving in terms of providing the right amount of information for manageability, for an observability aspect as well. So from a logging standpoint, what we did was to leverage some of the Cloud Foundry marketplace services, log management service, which enabled us to stream the logs into a common console. And another key aspect which is absolutely required in a microservices world is the traceability aspects, where you would want to do tracing of end-to-end transactions. Now, typically, if you are looking at it in a traditional way of implementation, you would need a lot of boilerplate code which needs to be inserted into the actual microservices to enable tools, any other traditional tools. For example, with Zipkin or Jaeger. Now here, again, Zipkin is something which is available as a part of the Cloud Foundry platform. And with minimum integration of binding to the service, the trace ID and the span ID, those details are added as part of the header details, which will enable us to be able to do end-to-end transaction flow, which means lesser code and more manageability aspects are covered as well. Coming to the monitoring as well, in this monitoring aspect, so again, there are ways to monitor things. What we thought was to look into the ELK solutions. We took the ELK stack, which would, the reason being adaptability of it, and with enterprises have been using this Elastic stack for various reasons. It could be for log monitoring, log analytics. So we used that to channel out the information to the log stash, and then we provided more into the log analytic aspects. Finally, another aspect is on the auto scaling feature in terms of how we can increase the elasticity. Again, there's a nice feature out there in the cloud application platform, which we leveraged. And there are different ways of handling this auto scaling aspects, mainly in terms of having what we did was to have a feedback driven event approach, where we leveraged the monitoring events of the cloud application platform, and then monitor the application resource consumptions and the triggers. And that's how we were able to scale the application services. But of course, we need to make sure that our services are as stateless as possible for easier management. And these are some of the interesting features that we have taken care in the solution realization, with which we were able to manage the key things. So the result of this is that we were able to have a distributed scalable platform with the help of elasticity coming from the underlying AWS infrastructure, and with the overall application lifecycle management through SUSE Cloud Application Platform. And then we think it's going to be a nice and scalable solution, which is highly resilient from an application management standpoint, and satisfying the business requirements of the end users. So from the technical standpoint, from an approach perspective, we do see quite a bit of advantages in terms of reducing the time to deployment, because the developers are completely oblivious to the Kubernetes underlying complexities. And with the help of build packs, it actually reduces the dependency from the developer standpoint. And these help us to actually manage the overall and with zero downtime, almost zero downtime. So this is to summarize my observations and how we have managed it. Thank you. Yeah. So this is summarizing the benefits.
Thank you very much, Srikanth. It was fantastic to hear about your journey through to modern application practices. So to get started, you could follow the link below to start having a look at the platform, and feel free to contact SUSE and tell them about your use case. From here, I think we'll go to Q&A. And for that, I'll hand over to my colleague, Ryan Nitsch. Ryan, are you there?
Yes, I am, Jay. Right, so we have in your interface in front of you the ability to pose questions to the panelists on this webinar. So please take the opportunity to throw any questions you may have at us around SUSE Cloud Application Platform running on AWS, and we'll address those. We've got sort of, 10 minutes left. One of the questions which was posed a little bit earlier today was, are we going to be releasing this presentation and these slides? Yes, in the next few days, we will be sending all of the presentation content out to all of the attendees on this session. There will also be several follow-up items coming out over the next weeks and months, so do keep an eye out for those. I just want to see, are there any questions that myself or Brent and the team from SUSE want to jump in and address, which have already been asked?
There's a couple in here that I could quickly take care of, if you like.
Yeah, sure. By all means, let's jump in.
Sure. So some of these are pretty straightforward and might have been answered since the question was asked. But in any case, one is, how is this different from other Cloud Foundry distributions? So again, the primary difference is that we are containerized and run inside Kubernetes, whereas other traditional Cloud Foundry distributions are VM-based, and they're managed by a different complex but powerful tool called BOSH. So with SUSE Cloud Application Platform, it's just a lot easier to get started with, assuming that you're already using and familiar with Kubernetes. Another one was, is there a UI? Yes, we have a UI we call Stratos. That was originally developed by SUSE, and it now belongs to the Cloud Foundry Foundation, and it's still managed by us, where we're the developer leads on that. It's 100% open source, and there's contributions from other companies as well. And another was around, I guess, around build packs, without using that term, is what languages and frameworks can be used with SUSE Cloud Application Platform. And the answer is pretty much anything you can think of. So we use an open source technology called build packs. That's now part of the Cloud Native Computing Foundation. And what that means is you can find a build pack online for literally anything you want. You know, I don't think I've ever heard of anything you can't get. There's even Fortran and COBOL build packs available, if you can believe that. Troy, did you want to maybe answer a couple of the more technical questions on here?
Yeah, I'll just follow up a little bit on that, the build pack question. I'm Troy Topnick. I'm a product manager for SUSE Cloud Application Platform. And in addition to the fact that you can really find a build pack for anything, we do ship core build packs for Java, Ruby, Node.js, Go, Python, PHP, .NET Core, which is Linux native .NET. And then there's build packs available if you want to run an arbitrary binary that you've built, or just a static website. And we've got new build packs coming for R and a generic Nginx build pack. There was a whole bunch of questions that came in. One of the ones recently that came in, I wanted to call attention to. was about what support is available for active disaster recovery across regions in AWS. Cloud Foundry or Cloud Application Platform, you can't actually run a single cluster that spans multiple regions in AWS, but you always should do multiple availability zones. So what a best practice has been developed by some of our customers in the past has been to deploy applications to multiple endpoints. Now they've automated this with CI/CD to keep them in synchronization, and then they've tied those services to keep state and the back end with database services that span the region. So because we support the AWS Service Broker, you can actually tie those application instances running in different regions into an AWS data service. So you'd keep state in something that spans regions, and then the actual disposable application instances, which can come up and come down, would be running in separate endpoints in different regions.
So that's in line with many designs that we're seeing from customers running on top of AWS, really taking advantage of those availability features such as multiple availability zones, the native AWS services that are already multi-AZ capable to give you that resilience within a single region, and then building out another cluster or another environment in a different region, and then catering for the replication of data, or as you said, pushing application code to multiple endpoints. If there are customers on this session who want to dig into that sort of design or have discussions around this, I do encourage you to open that dialogue up with the account teams that you're working with, and we'll happily sort of discuss that within the context of your specific requirements.
There's some new questions that are coming in. I wanted to go back to an interesting one from earlier, which is, when should I use Kubernetes on its own instead of Cloud Foundry? And that's a really good question, and it's one that we don't want to be too opinionated on, because of course Kubernetes is a fantastic container scheduler in its own right, and you can run applications by deploying them directly to the Kubernetes API. We don't want to belittle that at all. We just want to make it really obvious that what Cloud Foundry brings, the Cloud Foundry API, is a workflow that allows developers to focus on their application code and not have to worry about the infrastructure. They just do a CF push command, and their application code is automatically handled. So we find that Cloud Foundry's workflow works better for developers who are developing new applications and iterating rapidly over code, whereas Kubernetes is better for sort of a lift and shift operation. If you want to get your code into the cloud, you can containerize it, you can package your application, and you don't have to have the developers involved in rapid releases of the product. That's where Kubernetes might be a better fit. Also for if you have to do very specific routing or very specific inter-pod networking, if you have to take advantages of some of the Kubernetes features, then you might choose to package your application specifically for Kubernetes. There's just a lot more work involved in getting it ready for Kubernetes than it would be for deploying to Cloud Foundry. There was a question asked, is SUSE the only Linux OS supported? Cloud application platforms all built on SUSE Linux Enterprise, but for the developers, we expose two base containers for the build packs to work on, for the applications to be deployed in. As part of a certified Cloud Foundry distribution, we have to ship CF Linux FS2, which is an Ubuntu-based stack, but we also provide our own SUSE Linux Enterprise-based stack, which is completely compatible with all of the build packs. Sorry, there's some of the ones I tried to notate in the answers section a number of things, but some of the newer ones coming in I haven't answered yet, so I'll just answer them verbally. For a developer, this one from Adam, for a developer, what are the steps to get a service to become a running container microservice in your platform? It depends what you mean by service or microservice. If your microservice is essentially a web application or an application that is responding on a RESTful API, you would write your code in one of the supported languages, authenticate with the CF API or the CAP API, and with the CF client, you would do a CF push command that would push the code. The code would be inspected by the build pack. The build pack would execute an operation called staging, and it would expose that application or microservice on a route that is assigned when you push it, or you can assign a route of your choice as well. Basically, anything that you can find on microservices in Cloud Foundry applies equally to SUSE Cloud Application Platform. The next question from Bingju, what files does SUSE Platform deploy, source code or binaries? You can deploy either. It very much depends on the build pack. Some build packs take just raw source code. Other build packs, typically people using Java, will actually compile their jar file before deploying it. And of course, you can actually deploy containers directly using the Cloud Foundry API. So if you already have a container in a registry somewhere, you can use the CF push command to just push that container. So there's a number of different ways that you can deploy your code. The typical workflow is to deploy source code directly from a local file system using the CF push command. Does your platform work for the global web applications which are tightly coupled? I don't really know exactly what that question means, so I'm just going to skip it for now. If you mean by that the web applications are tightly interconnected and need to talk to each other, this is certainly a possibility. As long as you have network line of sight, you can couple these applications. But as always, latency will factor into how you design them. If something is, if microservices are talking to each other across the globe, you have to factor that in when you design your microservice system. Does your platform deploy the client apps to tens of millions of client computers? Well, if you mean does this is no. So this platform is designed primarily for web applications. So we're talking about a platform that is supporting server-side applications. There's a question there for Wipro that I will let them answer. Could Wipro expand on their microservices expertise or services offered? Does anyone from Wipro want to answer that last question?
Yeah. So, so on the microservices perspective, Wipro actually focus on 3 areas. One is actually transforming the applications into the more of a microservices to a domain-driven design, which is a more of a consulting services in terms of what approach that they have to take in terms of breaking the monolithic applications into the microservices and doing the right architecture and right technology components to choose to implement those applications. So that is one area that Wipro offers the services. And the second one is actually creating the platforms, because the microservices definitely requires quite a bit of capabilities in terms of the reliability and the defensive engineering and scalability, agility, observability, and data integrity. So there's a lot of capabilities which are required, and we need to have the robust platforms to manage all those capabilities. So that's where Wipro has a dedicated engineering lab who actually experiments with a lot of these next generation technologies and open source components, and which pre-integrated them to address most of these capabilities. That is more in terms of the platform part. And the third one is more in terms of as the lot of new generation technologies are evolving and which are being used to build the smart architectures and build these microservices based applications, right? Which requires a cultural shift within the organization, and it's a new way of development and new way of delivering these applications using some autonomous software delivery components and things like that. So that's where Wipro can help the enterprises in terms of defining the new ways of working and delivering these softwares much more faster. So that's what we offer when it comes to the microservices.
Awesome,
Sri,
thanks.
and another question for you guys at Wipro regarding the solution that you built. There's a question around, in the final solution, is there any sort of Java, Spring, or Spring Boot components that were used as part of building out that solution? Is there anybody from your side who can dig into that?
Yeah, so the most of the microservices comprising the business logic is actually built on a Spring, and which are exposed as an APIs or the REST endpoints to the node, and which has been consumed by the AngularJS. So that's how we have built our application.
I think we have covered the vast majority of questions. There is one left referring to a link, and I'm not quite sure which link is being requested.
I think that was from the previous slide. So if we could just paste that in the answer section, that would probably answer that. There was another interesting question on the typical hardware requirements for a production cluster, which I could get into very briefly. And the answer is actually depends totally on what your production requirements are. So as Brent mentioned, the footprint of a containerized Cloud Foundry is much, much smaller than a typical Bosch deployed virtual machine Cloud Foundry. So I typically run a high availability cluster on Amazon using only 3 M4 extra large worker nodes, and I can have multiple Diego cells for running the applications within Cloud Foundry. I can have a couple of routers. I can have multiple instances of all of the roles within Cloud Application Platform for redundancy. And in addition to that, there's some requirements for GP2 storage class, fairly modest. Again, it depends on how much file system space you need for your applications, and 5 ELBs. So it's a very small footprint for a fully highly available system. And then as your usage grows, adding to that is extremely simple. You just add more nodes to your pool of your Kubernetes pool in EKS.
So the AWS and SUSE teams are working very closely on building out a reference architecture. This will be released rather soon through the AWS Quick Start program, and you'll be able to take advantage of a CloudFormation infrastructure as code template to stand up the entire environment, and that reference architecture will provide an architectural guide in a written document that can be used for comparison to scale workloads and addressing concerns within your business. So do keep an eye out for that under the AWS Quick Start page, aws.amazon.com/quick start. Jay, I don't know if we are able to provide any insight as to when that will be launched. I imagine that we don't have a ETA on it as yet.
Not at this time, but keep an eye on the page, and when it does finally land, I think it will be super useful for customers to be able to get a really good reference architecture on AWS that's gold standard. It has all of the HA stuff baked into it, and it's really flexible for getting started really fast with running SUSE Cloud Application Platform on AWS in prod.
Right, and that gets us to the top of the hour. Thank you everybody for joining us, and as we said, we'll be sending out this presentation deck to all the attendees within the next few days, and have a smashing remainder of the week.